Hello guys and welcome to these C tutorials. So we're going to be learning C programming from basics to pro level. So whether you're a complete beginner or you're someone that has experience, so everybody, this course is for anyone who wants to master coding from ground up, anyone that wants to learn how to learn the foundations of modern programming, because C is the mother of all programming languages. Now, if you're an absolute beginner, this course is for you. If you're a student doing computer science, IT, or any engineering related field, this course is for you. If you're a developer that wants to understand how to write code that can control hardware, this course is for you. If you're preparing for a tech interview, this course is for you. If you want to go into embedded systems and building embedded system, then this course is for you. Now, what are we going to be learning in this course? We're going to be learning introduction to C. We're going to be looking at basic syntax of C and data types. We'll look at operators and expressions. We'll look at control statement, how to control the flow of your program. We'll look at functions. We'll look at arrays and strings. We'll look at pointers. We'll look at structures and unions, file handling, memory allocations, and advanced features such as bitwise operators, creating and using header files, preprocessor directory, links list, stacks, queue, in fact all data structures also in C. Now we'll hit right away with the beginning of the course. This course is going to be a complete practical course. So, but for this first lesson, I'm going to allow me to do some literature part of it for like the next 5 minutes. So, why should I learn C? C is the foundation for many programming languages like C++, Java, Python. Learning C gives you an upper hand to bounce on Python programming, to bounce on Java programming, to basically understand how these other programs work. C is a procedural language. It's not an object-oriented programming language. C is used for building system level programs such as embedded system operating systems. C, what made C to become popular after it was released by Dennis Ritchie at the Bell Lab as a potential replacement for the B language, was that C was used to build the Unix operating system. So it just made C to be wow, and everybody just started going for C. Now, key features of C is that it has a rich library full of input and output, right? It's made of math in string libraries and much more libraries. It's a procedural language, right? I said before, that's not an object-oriented language. It's based on functions and procedure. It's fast and efficient. It's portable. I can write C program here and run it in different computers. Like when I download Office from the internet, I can easily just execute it and have Office on my laptop. So it's modular language, which means we can break C into smaller functions or smaller modules. Now let's look at the basic structure of a C program. So a C program, this is where the real deal starts, right? A C program is made up of, we start with the hash include, right? So std.h, stdio.h, stdio stands for standard input output dot header. So it's a header file. It's a preprocessor directory. Then we have the main function. So every program starts executing from the main. So main is a function and it marks the beginning of your program. Then we have the printf statements, which is we have bracket, and then we have some text, formatted text inside. And so we have the hello world is the text that we want to display on screen, and \n is an escape character. Then it ends with a semicolon. Every statement in C ends with a semicolon, except when you're doing the hash include, that you don't do the hash include stdio, that you don't do the semicolon there. Then we have return 0, which exits that scope, right? And we're using return 0 because the main function does not actually give us anything back after we run it. So basically that is the basic structure of a C program. Now I'm going to write this C program, and I'm going to I'm going to be using code block, right? So you can use whatever editor that you want to use, and later on I'm going to talk about the compilers that you can use. So note that C is a compiled language, right? Which means that when you write your C program, you must compile it before it works. So while I'm writing this program, I'm just going to get to be explaining some other stuffs, right, that are important. So when you run a C program, right, when you want to compile a C program, for example, this one that I have written, so I can compile it, right, since C is a compiled language, which means that what actually happens when you run a C program, right, when you compile a C program, right, this is what happened. I've written this program, it is in human readable form, so it is in high level form, right? And now we need to be able to, when you compile, right, what happened is the first thing is that the preprocessor headers, right, these ones, right, everywhere that you start, anything that starts with this, right, the preprocessor will handle that. Then it will expand the macrons, including the header files, and remove every comment. So if I have a comment here, like, okay, this is a comment, right? So it will remove all the comments, right? And then now what happened is the compiler now will translate the pre-processed code into assembly code. What happened is, now this is my hello.h. It will be from preprocessor. It will do it. It will translate it to pre-processed code, which means it will remove all of these comments will be ignored. That is completely removed. These lines will be removed. Right. So this then another thing that happens is that now the compiler will now come in to compile this pre-process, will translate the pre-processed code into assembly code specific to their CPU. Now during this compilation process where we are translating it into assembly code, so I have a .c here and it will become a .s. Now this phase is what is not seen, right? So definitely you will not see it when the .s file is created. So it will go to assembly code. Now this assembly code now, during this compilation process, we're going to check for syntax error. For example, if I have a syntax error like this, forgetting a semicolon, and I try to compile this file, right, it will compile with an error that there is an error at line 12, right, before my return statement. So it checks during that compilation process. Now, if it compiles successfully, right, if it compiles successfully like this, sorry. If it compiles successfully like this, right, now what happened is my .c code, which has now turned to .s code, right, in assembly code, the assembler will now convert this .s code to a .o code. That's object file. It will create an object file. So it will now be a hello.o. Now this is now in binary format, so I'm going to put here binary format. So binary format means it is in zeros and one, and that is machine language, right? That is fast to run on hardware components. Now, but at this time, this is not yet the executable file. So we have what are known as the linkers, right? So we're going to do something like a linking. Now all this file that was included here, the .h file that was included here, the .h file is made up of other components that contains the printf statement, or what the printf is supposed to do, what return means, what int num means. So what will happen is it will now link up these files with any external function that is available, right? Any external function that's available, like the printf, such that it will now use all of that to create the executable program. So you now have a .exe file for Windows or a .out for Mac and Linux people. So if I just compile this again, right, I'm going to compile and I come here. So I have, this is what I'm saying, right? We have our C source code, right? So C source code application. So this is our application file, and this is the hello.o file, which is the object file. This one is not executable. This is the one that is executable. Now I can port this one and give it to somebody, and the person can run it. So once the person run it from his computer, it's going to print hello world on his computer. Right. So basically, this is how a C program works. So if I have like, okay, let me do another print F. C is fun. Right. So if I compile, right, and I run again, right, if I compile and I run again, so it will now print me C is fun. So now look at something. I have hello world, then C is fun, because I'm not using the backslash here. All right, so that's why I said that backslash was an escape character. So I build and run and \n. So I'm going to compile and run again. So basically this is what happened when you compile a program. So in this video, we've learned what is C will look like, kind of the history of C, and we've seen how to write a simple program in C and how to run a simple program in C. Now, what are the common compilers that we can have in C? So we have the GCC, which is for Mac, Linux, and Windows with MinGW. You can download that directly from online. You have TurboC, which is old. I don't think anybody used TurboC. You have CLang, and also you have Visual Studio C compiler. So if you're fond of Visual Studio, right, you can use Visual Studio and you use that. Okay, so in this video, in our next video, we're going to look at the basic syntax and data types of the C programming language. Like, share.